For the nomenclature activity, we will be naming compounds. The first thing that we have to do is decide what kind of a compound is it. Our three choices are ionic compound, molecular compound, or an aqueous acid, which we often just call an acid. Remember that ionic compounds can be called salts, molecular compounds can be called simply molecules, and aqueous acids, acids. Okay, so an ionic compound, it contains a cation and an anion. A molecular compound contains, at least if they're the type that have only two different elements, they contain two nonmetal atoms. An aqueous acid contains one or more H+ ion attached to an anion. Now back to the ionic compounds. The cation is often a metal cation. It's often, for example, sodium ion or potassium ion or chromium ion or aluminum ion. The other metal cation, or the other type of cation it can be, is ammonium ion or mercury ion. That is Hg2 2+. That's a polyatomic. Otherwise, it's usually a simple metal cation that you recognize as a metal. The anions can be simple anions like Cl-, like O2-, or they can be polyatomic ions, like given in the example here, NO3-, nitrate, SO4₂- sulfate. Okay, so step one, decide what kind of a compound is it? Ionic, molecular, or an acid? If an ionic compound, we name the cation and then we name the anion. Often the anion ending is IDE. Not always. Okay, so here's a periodic table showing the charges, some of the charges that elements take on when they become charged. If it is an element from group 1A, and a metal like lithium, sodium, potassium, etc., it has a +1 charge. If it is from group 2A, like beryllium, magnesium, calcium, it has a 2+ charge. So just by virtue of the position on the periodic table for the metal, when it becomes an ion, we know the charge. If it's from group 3A, like aluminum, it becomes 3+ charged. If it's an anion that's a simple anion, it's just composed of one element, and it's from group 7A, that would be the halogens, and it's an ion, it becomes -1, F-, Cl-. If it's from group 6A as an ion, it becomes 2-. So we have O2-, S2-. If it's from group 5A as an ion, it becomes 3-. So N3-, P3-. So just by virtue of their position on the periodic table, when they're an ion, we can predict their charges. That holds true for group 1A, 2A, 3A, 5A, 6A, 7A, but it doesn't hold true for the transition metals, the ones in the middle, like chromium, iron, and for tin and lead. So those ones can have variable charges. They're shown here in blue. Now, for the transition metals, except for silver and zinc and what's below zinc but not shown here, cadmium, their charges are always, for silver, 1+, for zinc and cadmium, 2+ when they become charged. But for the other transition elements on the periodic table, they can have variable charges. Copper 1 plus common, copper 2 plus common, Fe2 plus, Fe3 plus. Some of the transition metals, like manganese, not shown on this periodic table, can have charges that go from 2 plus all the way to 7 plus. So we have to indicate the charge. With tin and lead, we commonly have tin 2 plus or tin 4 plus, and with lead 2 plus, lead 4 plus. So when it's one of those elements that has the variable charges, again, they're shown, some of them are shown here on the periodic table in blue, we indicate the charge of the cation in Roman numerals, like Cr2 plus is chromium 2 when we say it. Cr3 plus is chromium 3. Iron 2 plus, iron 2, iron 3 plus, iron 3. The ones that have the set charge, like lithium, sodium, potassium, those ones we do not have to indicate the charge. We simply give the name. The anions that are the simple anions, hydride, fluoride, chloride, so they're just composed of one element, we give the root name from the periodic table, like for fluoride, fluor, chloride, chlor, and then we have the ending IDE. So we put that together, naming the cation, naming the anion. Now, sometimes we end up with a polyatomic ion. So for the cations, the polyatomic ion that's common is NH4 plus. It's a cation because it has a charge. Yes, it's composed of nonmetals, not a metal, but anyway, it's just one you will have to remember. That's called ammonium. The other common one, though not shown in this table, is Hg2, 2 plus. That would be called mercury 1. You'd put the 1 in Roman numerals in parentheses. Otherwise, in our table here, we have a whole bunch of polyatomic anions, acetate, carbonate, etc. So look here or in your chapter 2 lecture handout for what to name the polyatomic anion. Now, going back up here to these examples, NaOH. So we can say that as NaOH, but if we have to name it, we would name it sodium hydroxide. MgNO3 is composed of Mg2 plus and 2 NO3 minuses, that is magnesium nitrate. Cu3PO4 is composed of copper 2 plus and PO4 3 minus phosphate. Now, copper is one of those that can have variable charges. It can be copper 1 plus or 2 plus. In this case, it's copper 2 plus, so we would name that copper 2 phosphate. Even though in this example we see a space between copper and the 2, we usually don't put that space. Okay, so that is naming that is naming ionic compounds. How to name molecular compounds? It's those, the non-metal ones, where we end up with those prefixes mono, penta, hepta, and so on. So again, molecular compounds contain only non-metal elements. And in the example here with nitrogen and oxygen, we can have NO, we can have NO2, we can have N2O4, we can have N2O4, we can have N2O5. Anyway, there's a whole bunch of nitrogen, oxygen molecules out there. And so we have to differentiate them, indicating how many of each element there are with these prefixes mono, di, tri, tetra, etc. Unless the first element, there's only one of them, we leave off the mono. So look to this table for the prefix name given the number. Our examples, N2O3, so that would be dinitrogen trioxide. Notice that for the first element, we give its full name, we would see on the periodic table. For the second element, we give the root followed by IDE. PCl5, so that's phosphorus, no mono in front, just phosphorus, phosphorus pentachloride. CO, carbon monoxide. Notice we've dropped one of the O's for ease of pronunciation. P4O6 is tetraphosphorus hexoxide. We dropped the A just for ease of pronunciation. For the acids, we have the acids without oxygen and we have the acids containing oxygen. Now remember that acids contain H plus combined with some kind of an anion. Okay, so if they have no oxygen, then we have hydro in the front. We have the root name of the element other than hydrogen, followed by ic acid. So HF, hydrofluoric acid. HCl, hydrochloric acid. H2S, hydrosulfuric acid, where we actually don't just give the root for sulfur, we give the whole name sulfur. The ones that contain oxygen, so those can end in us acid or ic acid, depending on, well, how many oxygens they have. So HNO2, you could say that comes from H plus and NO2 minus. NO2 minus is nitrite, ending ITE. How do we know it's nitrite? Well, it's on that table that has the polyatomic ions. Now, when we have the ite anion, then when we name it as an acid, we end it with us acid, OUS acid. So we take the root name, nitra, and then we end it us acid. HNO3, that comes from nitrate, and when we have a nitrate as the anion, or when we have an 8 anion, we have the name ending for the acid, ic acid. So we have the root there, nitra, and then ic acid. H2SO3 versus H2SO4. So SO3 2 minus is sulfite, SO4 2 minus is sulfate. So the ite becomes us acid, the 8 becomes ic acid, so we have sulfurous acid and sulfuric acid. Acetic acid, that has the H plus and then the C2H3O2 minus, which is acetate. So ATE ending becomes ic acid, so that's why we have acetic acid. Alrighty, so that gives, in this table, it gives some of the common acids. So look there for naming and apply the rules that we've talked about. All right, so the summary, the type of compound, if it's ionic, that is to say if it's a salt, then we name the cation, we name the anion. For the cation, sometimes we need the Roman numerals depending if it's got variable charge. So sodium chloride, this FeCl3, well, we have iron 3 because we have one of those with 3 Cl minuses, so we deduce that the iron must have a 3 plus charge. So we have iron 3 and then chloride. NaNO3, that's sodium nitrate. FeNO3, so there we have again the Fe with a 3 plus charge, so we have for the cation iron 3, and then we have nitrate for the anion. If it's a molecule, then we have the prefix element plus prefix element root ide. So N2O3 is dinitrogen trioxide. If it's an acid, we have those non-oxygen acids, so hydro, root name ic acid. If it is an oxygen-containing acid, if the anion is an 8 ion, we have the ending ic acid, so we have root ic acid. If it is an ite ion, then we have the root name us acid. Alrighty, so you don't have to do the pre-activities, don't submit it. You do the report, so you put your name, don't worry about lab section. So in the first problem, we are identifying what kind of a compound is it, ionic, molecular, or acid, and based on what type it is, we name it. In number 2, we're simply naming those. In number 3, we're providing a name or we're providing the formula given the name. And that is it. So when you've got that done, then do scan it, prepare it as a PDF file, and submit it.